Okay, so recall that we discussed that how we can load the data in a register. So let me pull up this whiteboard here. So to load the data, for example, if I use the add instruction, add and if I have to load some data into x19 register, I can just simply write x0, and let's say I want to load some value, let's say 9 or something. Okay, so this 9 is represented in 12 bits, right? So this 12 bits, whatever the value is, actually 1001, 000, 0, and then another 12 bits. Okay, so these 12 bits are loaded into x19. First, they are actually the sign extended into 32 bits, and then it is loaded into x19. So whatever, so if you have the registers here, so x19 will now contain the value 1001 and all zeros, depending on what the instruction and what the sign bit is. Okay, so imagine that we have to load some value which is greater than 12 bits. So suppose that we have to load the larger value, and we discussed that we can do that with the help of LUI instruction. So LUI instruction help us load the upper immediate value. So we specify the destination register, let's say x19, and then we specify the uppermost 20 bits value. Let's say in hexadecimal format, it could be 1, 2, 3, 4, and 5. So each bit, that represents the 4 bits in the hexadecimal representation. So this 4, 4, 8, 12, 16, and 20. So this is how we load the upper 20 bits into the x19 register. And next, what we do is if we have to load the total value is 0x1, 2, 3, 4, 5, 6, 7, and 8. For example, this is the 32-bit value. So the LUI instruction will help us load the upper 20 bits, and then what we do is we do add x19, and again x maybe 0, and then what we can do is 0, 6, x 6, 7, and 8. These are the 12 bits which will be loaded in here x19. Sorry, this should be actually x19. So whatever the contents of x19 are, which is 1, 2, 3, 4, 5, and then 0, x 6, 7, 8, it all together, it will load the value in this register, which is 19. Let's say it's 19. It will load the value 0, x 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so let's go back and move on with the next discussion. So we have already discussed that the LUI sets the higher 20 bits and ADI sets the lower 12 bits, immediate is sign extended. So if you have that LUI x19 0x3D0, so although we have specified the 3 hexadecimal digits, which means 12 bits, but whenever we use LUI, so it will append zeros on the left hand side. So this value is actually extended into this, and then this entire thing will be loaded into x19 while keeping this thing unchanged. Okay, now to add the remaining value, which is the 500, what we do is we perform the add I x19, and 0x 500, and it will load the remaining 12 bits on the rightmost side, right hand side, into x19. Okay, so which format we can use to represent the binary instruction, the machine instruction for LUI? So we already know that add I follows the I format. What about the LUI, where we have immediate data and only one RD? So there is a special format called the U format, where we have opcode RD and then the 20 bits of immediate data. Okay, so the higher 20 bits of the 32-bit immediate the processor gets. Okay, so the opcode of LUI is this. Again, this is just a representation to make things clear, and 0B corresponds to the binary representation of this data. So this is the opcode for LUI. So whenever a processor reads this value at the rightmost 7 bits, and it will immediately understand that the LUI operation has to be performed, and it will treat all the remaining this 20 bits after the RD field will be treated as an immediate data. Okay, so the example here is you specify LUI x1 0 A B C D E. So this is the thing that you get A B C D E. This is what you specify in as a 20-bit immediate data in the instruction. So this is the opcode. This is the RD corresponds to x1, and then this is the immediate data. Okay, so 32-bit immediate data the processor uses is 0xabcde000. Okay, because it has to store the 32-bit data into a register, because every register is 32 bits wide.